This video briefly introduces a bandwidth enhancement and size reduction of a low-profile polarization reconfigurable antenna by utilizing multiple resonances. The proposed single-fed polarization reconfigurable antenna contains 4 square patches arranged in a chessboard pattern, an I-shaped top-loaded monopole fence and a microstrip line-fed cross-slot. The reconfigurability of the developed antenna is achieved by switching the state of pin diodes that are inserted on the cross slot and microstrip line. Taking the left-handed circular polarization state as an example, one can observe that the 3DD's axial ratio bandwidth of referenced microstrip antenna is only 1.9%. By using basic multiresonance antenna comprising 4 chessboard patches and cross-slotted ground, the 3DD's axial ratio bandwidth could be enhanced to 16.6%. Then, by loading an I-shaped monopole fence around the chessboard patches, forming a wider 3DD's axial ratio bandwidth of 30.1%. Thereby witnessing an improvement of 15 times compared with the conventional microstrip circularly polarization antenna. The understanding of the operating mechanisms of this antenna was developed using characteristic mode analysis. A basic multiresonance antenna comprising 4 chessboard patches and cross-slotted ground generates and excites 3 sequentially orthogonal resonant modes. An axial ratio bandwidth enhanced circularly polarization antenna with dual recances poles is developed. In order to make use of the slot line mode for further circularly polarization axial ratio bandwidth enhancement, an I-shaped top-loaded monopole fence is loaded beside the chessboard patches to cooperatively regulate the slot line-based camp mode and the triple sequentially orthogonal modes to form a wider 3DD's axial ratio bandwidth. The optimized low-profile bandwidth enhanced polarization reconfigurable antenna were fabricated and measured. It is clear that the measured results are in good agreement with their simulate values. In summary, a polarization reconfigurable antenna with an overlap bandwidth about 27.6% is achieved without sacrificing compact and low-profile characteristic, and in the future, we plan to design an electric small broadband polarization reconfigurable antenna.